Section 27A is about square roots. We're going to introduce you with square roots. We're going to introduce you to square roots by defining what they are. A square root is one of two equal factors of a number. So if you take a number like 16 and you take the square root of 16, that means you have to find what number is the same as itself that multiplies to equal 16. And what we use is this little symbol. It's called a radical sign. And we say the square root of 16 is the number 4 because 4 times itself, it's an equal factor. 4 times itself is 16. So this is what a square root is. 4 is the square root of 16. And we use this little symbol called a radical sign. So I guess I can go down and put that there. Now, what's interesting is there are these numbers called perfect squares, and those are numbers whose square root is rational, which means it doesn't have decimals, doesn't have any fractions. These are a very special list of numbers, and I'd like you to make sure you have them written down. The number 1 is a perfect square. Why? Because 1 times 1 equals 1. Well, what does 2 times 2 equal? The answer is 4. So 4 is considered a perfect square because it can be created by multiplying a number times itself. Well, how about 3 times 3? 9 is a perfect square. 16, that's 4 times 4. 25, 36, 49 is 7 times 7. 64 is 8 times 8. 81, these are all perfect squares. 100, 121 is 11 times 11. 144, 169, 196 is 14 times 14, and then we'll stop with 225. Now, those numbers actually go on forever, but these are a very important list of numbers. They are all called the perfect squares. And the reason is because all of their square roots are whole numbers. Square root of 100 is 10, because 10 times 10. Square root of 25 is 5, which is why all of these numbers are called the perfect squares. Here I'm asked to find each square root. Well, the square root of 64. Remember, a square root means what value times itself will give me 64. Well, since 64 is a perfect square, I know that the square root of 64 is 8. Over here, the square root of 25 is 5, but because there's a negative in front, we end up saying the negative square root of 25 is negative 5. You take the square root first, and then you apply the negative to the answer. Here, the negative square root of 49 over 256. Well, the square root of 49 is 7. And 256, the square root of 256 is 16. 16 times 16. And because it's a negative on the outside, it's a negative. Now this little symbol, you can read it plus or minus. Is how I read it. That means plus or minus the square root of 16 over 49. Well, the square root of 16 is 4, and the square root of 49 is 7. Why? Because 4 times 4 is 16. 7 times 7 is 49. So we want the positive and the negative version of our answer. We want a plus or minus 4 over 7. Notice that when you take the square root of a number, you take the square root off. You don't rewrite the square root again. So square root of 16 is not square root of 4, it's just 4. Here we have to find the square root of some decimals, and these may look impossible because you don't know what to multiply two numbers to get decimals, but if you look again, this is really a 1.44. Well, the square root of 144 is 12. So what do you think the square root of 1.44 might be? Maybe 1.2? Let's take a look. What's 1.2 times 1.2? Placeholder. 1 times 2 is 2. So 144. But there's two decimal places, so 1.44. Yeah, it turns out it's 1.2. So even though that's close to 144, you can still find the square root because the number itself is a perfect square. How about 0.81? Well, 81, the square root of 81 is 9. Well, what about 0.81? Maybe 0.9 times 0.9. 9 times 9 is 81, 2 decimal points. That's correct. So plus and minus 0.9 is the square root.